and welcome everyone to the 16th project showcase in our initiative دعم الخريجين. In this initiative, which is presented by the Saudi Data Community, we aim to highlight the work of our community members by allowing them to showcase their graduation projects. In particular, we are focusing on projects which employ data science or machine learning. The goals we wish to achieve through this initiative are first to highlight data science and AI projects, also to showcase students' efforts and enable them to share their experiences and their stories, to present those projects to various sectors for the purpose of finding support for our community members. We also want to encourage and to educate prospective graduate students. We want to motivate them to delve into topics such as data science and machine learning. Last but not least, we want to enrich the community with good material and substantial knowledge in the field of data science. In this initiative, we are targeting recent graduates and technical projects, especially those employing data science and/or AI. We would like to thank our golden partner Quant and our strategic partner Education Statistics Center and Decision Support. Our project for today is titled Oil and Gas Forecasting. It aims to employ regression and LSTM-based machine learning models to predict stock values. Our presenter for today is Ilham Al-Baroudi, graduate from Cumbria University. Welcome, Ilham.
Hello. Hi.
Hi, Ilham. Welcome.
Hi.
We are very
First of all,
happy to have you. Oh, I just wanted to say that we're very proud to have you with us today, and the stage is yours. Please go ahead.
thank you so much for your this chance. I will talk about me. I'm data science with more than 3 years experience in data science and advanced analytics. I graduate my bachelor degree from Princeton University as software engineer. And then I complete my study in University of Cumbria in UK as a data analyst and AI. Uh, I am interested in fields such as computer vision, data mining, machine learning, speech recognition, NLP, natural language processing, deep reinforcement learning, deep learning, time series forecasting. This is my email if anyone wants to have chatting with me. First of all, I will talk about the table of content I want to have. The first one will start by abstract, the main component of any time series project, the implementation, the testing, and the conclusion. Let's go now to abstract. Stock predictions play a virtual role in finance and economy. Many people invest billions of creation in the stock expecting the profit after single stock. Depending on this behavior of market, there are ups and downs in the profits. Many people want to gain money from oil and gas. So they go to apply on that and start to see the ups and downs to gain the profit. So the problem of the fast and accurate forecasting of share prices, this problem solving by using machine learning and deep learning to predict the accurate forecasting of the stock prices, to know the exactly stock prices of the oil and gas using the capability of machine learning and deep learning. So the main component of the time series forecasting is the level component, trend, seasonality, reducibility, and basic situations. What that mean? For level component, we are talking about the average price. It's not all the time we are talking about current price. Sometimes we are looking for long-term average because it's not only depending on now, we are really need to search about past and the behavior. Trend, it's mean the running long periods, and the observation increasing and decreasing the value through the time. And we are see the trending, why now it's having a high price since 2 or 3 months. The seasonalities, like the period, the quarter, month, maybe you are talking about summer phase, spring, and etc. We also about longer 2 years. We are not only about this area, 1 year, 2 year. We are talking about more than 2 years, and we are taking a random variation of the data. We are not talking about only one behavior. We're taking randomly. What the issues we have, the fixed value, and the value does not change regularly. Sometimes the value keep in the same behavior with having the same fixed value, fixed price. The implementation I use the Python programming language. I use Jupyter Notebook. After I build the models, I turn to be API using Flask. The library I use TensorFlow for deep learning. I use Keras. I use some library, etc., like Pandas, MATLAB, and many other library. The challenge I have from idea to real, it was only an idea, and now it's become a reality. To predict the price and gold journey from 25 in December's 2015 in December's until now. The issues was the oil and gold are externally trended commodities. There are several microeconomics factors which affect this price. It's not only one factor that affects the price now. We have several factors can affect the price. The factors are have it in several ways. The first factor, and the next slide, yeah, the fixed factors is the factor affecting the price of oil. Of course, it's OPEC, sometimes non-OPEC, stock market, Sentinel effect, and the dollars. While which affect the gold, we are having something called consumer sentiment index, and the oil itself affect the gold price. And we have also features contracts, like maybe some countries buy gold rather than buying a dollar. So these features contracts are affecting that. Now, which model we have as a review? We have three of models: standard model, structure models, and non-standards model. What standards model are? Standards model, a serious model attempt to predict the oil and gas using the current and historical oil prices. And this is the famous way to predict time series, to analyze the previous and the current data. These models are useful in the following scenario. The price show autocorrections and autoregression behavior. What that means? There is a better significant correlations between the current and the previous price. We are see there is correlations between the current price and several 10 or 20 maybe prices. There are a large number of experimentally value, and it's difficult to understand them well because they are interact with other in very complicated manner. It's not easy to understand the relation between them. And also forecasting the dependent behavior may require to predict the explanatory variable. The other type which we're talking about, it's called the structural model. This considers the price to be modulated as a function of current experimentally value, such as talking about OPEC behavior, dollar. The difference between standard time series and structural. Standard, we are looking for the whole historical data. I take one. Of course, we cannot use maybe as we watch 1 year, 2 years. We need to do a correlation, auto-aggressive models, while the structure model, we are depending only for the current data we have, like the OBITIC result, OBITIC behavior. While the non-standard and non-linear method, it's apply using, try to extract these modes of correlations, and they might to add the forecast oil price. What that means, the non-standard models is used to understand the behavior now. There is a difference between structural models and non-standards. Non-standards, we are not looking for any effects. We are looking only for the data, what's the change happening and why it's happening. While in structural models, we are looking why that happened, why we are using this data, why OBITIC have this result. And this is the difference between the three approach we can use to predict and analyze time series forecasting. Which data set I have? I consider the multiple time series of oil and gas and related microeconomics factors. From where I can get this data, I get it from several ways, from OBITIC result. Now the observations, when we are looking for the data, we can see there is a strong and positive correlations between the gold and oil price. And here we are see the several, let's say the several factories depending. Let's take maybe the USD dollars, the dollar value, and how it affect the oil and gold. We can see here there is a negative, positive, negative, strong correlations between oil and the dollar price. What that mean? That means each time we are increasing the dollar, the oil will decreasing. While based on that, we see the gold, each time we are increasing the dollar, the USD are increasing. So there's a difference, let's say, correlations between the oil and gold, and the factor itself affecting on that. Why you are using the correlation matrix, understanding the behavior and the effect between factories help us to understand why these factories change the value itself. So in the futures, we can analyzing these features and depending on them to predict the price. Some features it does not matter at all, so we don't need to use it. Like we have, say, something called NYSE value for the gold, and it's only affect 0.70. So it's not make sense to have it in our relation because it's a weak positive correlation. If we have it, it may affect, but it's still in very rare happens. Now the baseline models. We have two baseline models. The baseline model one, the price stay at the same as the previous months. The other one, it's the price are cube weight average of the last 3 months. What that mean? If we are talking about the standard model, as we're talking in the previous slide, we need to have the current and the previous data. Sometimes we are only depending on 1 month, so the 1 month of the price is still the same. Why sometimes we need to have the average of 3 months, and this is two different baseline models. We can choose any one depending on the data and the change itself. The advanced models, sometimes we are using advanced models like auto-regression model, which mean auto-regressions model, or ARIMA, which is the famous one called as auto-regressive moving average models. We have also multiple linear regressions, and we have regressing using the future data models. The final predictions and the conclusion, what we really are trying to have, we're trying to have the final predictions of the data and see the relation error percentage will lie the current data. We try to have the oil prediction price and the gold price predictions. After we analyzing the difference between them, the colorations, analyzing the data, the behavior, the current value. Now, the method we have the first one, how to apply that. We have data preparation and data explorations. Data preparations, we choose the data, the stock price, normally stock from 1972 and over 10K observations. And also we are trying to see the data from 2014 to 2018 to see the, let's say, the change happened from this data from 1972 and 2018. Now the explorations, we are seeing the X and Y axis of the data. We are talking about which X and Y axis. The X will be the time series in the month and year. We are talking about month by month for 1 year. And the Y-axis will be the price change to understand the relation happen between the time and the price. The difficulty overcome, what's the difficulty I have when I start the project? I have the difficulty in missing the data, influence adjustment, data unavailability, downloading the features data, outliers in the futures data. What that mean? The missing data, sometimes for 1 year, I have missing data for some days. And the adjustments, influence adjustments, sometimes we are changing very huge moving, like the price change from very low price to huge price in less than 3 to 4 months, and that affect the colorations itself and affecting the data and the relation between them. The data unavailability, sometimes there are certain factors could not be including due to the unavailability. What that mean? Sometimes the euro and USD change rate are changing from time to time and from countries to countries. It's not like the same price at all. Downloading the future data, downloading approximately 365 days, reading them into a single data frame was a challenge. We are talking about 365 days for 1 year, and we need to download them and merge them using inner join to 1 year to have for 2000 maybe 40 we're having a 1 year data. The outliers in the future data, some changing, may affect that. Some, like let's say minus 0.1 or positive 1 outliers has error because we are changing from positive coloration to negative colorations. Testing, while I am testing, I use the LCMT model to understand and do the functional requirement I write and to see the historical accuracy depending on the future price. The test cases, which test cases I have? I will test the application itself. After I finish the model, I build the small applications and I build API that read the previous data and provide future data. I also test the accuracy of the models. As you can see here, I testing many autoregressive models and the relation between them, which one the positive and which one have the numbers, the less number of error. Conclusion, as a conclusion, I see the autoregressive model with ARIMA have a relevant 6.78% error for autoregressive for the predictions, while we have for advanced model 2 itself We have 6.1999 for the gold error. So I agree that the Aremia model here itself is the best models for predict oil and gas price. Here some reference I used while I am doing my research. You can also go through it to gain more informations about machine learning and gold mining, increasing the violation risk. Thank you so much. I hope you enjoy the journey. If anyone have questions, please ask.
Thank you so much, Ilham. This was a very informative presentation, mashallah, and you have done a great job.
Thank you so much.
Uh, you have spoke about some of the difficulties that you faced, such as data unavailability and such. While you were working on this project, what is one thing that you feel you needed the most?
Can you
Something
repeat
that
the question?
so while you were working on this project, what is
Yes.
one thing that you feel you needed the most? You said you faced a lot of difficulties. What is the most difficult one, and that
The
you needed
data
the
is
solution?
unavailability. Really, the
Yes.
data is unavailability.
Uh,
The lack of source of the data, the free
mhm.
data and open source data, it's a must one. We need sometimes to pay for data. Data is not free.
Yes. Yes. From experience, I agree with you too. Another question. So, as you know, part of why this initiative took place is that you want to help to motivate the prospective graduates. Uh, what advice would you give them based on your experience?
Machine learning and deep learning is not a hard, it's not a hard majors, but you need to
Mm,
start, really have a good start, know what you
mm,
really want to do, starting from the basics, starting from what's machine learning, why we want to use it, then grow up to be computer vision, time theory, NLP. But really, we cannot go to any topic without starting by what is machine learning. It's a basic one.
yes. Yes, I agree with you. You start with the basics and then you look
Grow up.
deeper. Yes, very well said. Thank you so much, Ilham, for your participation, and we truly wish you the best in the future.
Thank you
Thank you
so
to
much.
everyone who has joined us, and we will see you with another project showcase in the future, inshallah. Thank you one last time, and goodbye.